I just want to give you some feedback on the BMS105 Introductory Chemistry practical on the reduction of benzophenone to diphenylmethanol. This practical involved a lot of different procedures. So you had to cause the reaction to take place after you'd made up the solutions. You had to then allow the solution to stand for 40 minutes. You then had to on ice precipitate out the product, and then you had to purify that product, measure the yield and do the melting point. So there's a number of things you had to do within the overall procedure. So you had to write up the procedure in the past tense, and you had to make sure that you reported that impersonally. So just as has been done here, for example, benzophenone was dissolved in 25 centimeters cubed in ethanol in 100 centimeter cubed conical flask. And one of the things that I'd encouraged you to do was to avoid beginning a sentence with a number. So to try to structure your sentences in such a way that any number appears further into the sentence and not at the very start. Otherwise, it's better practice then to actually spell out the number in terms of words. So you wanted to have a paragraph, and I'd already mentioned this to you, a paragraph or a couple of paragraphs, but certainly no bullet points. And this was to write up the procedure in the past tense. You then had to record the yield. Now the yield at this point was just simply the mass in grams that you had managed to obtain. So this was the part at the very end where you were able to just on the balance weigh out how many grams or milligrams of material that you had produced. So you had to just record that. You then had to record the melting point, and the melting point should have been somewhere in between 65 to 67 degrees. Many times what happens is whenever you make a compound, if it's not completely dry, it still contains some water. If it hasn't been well purified, it has other groups in there, other compounds in there, and that many times depresses the melting point, so it's actually lower than what it should be. So the melting point is actually a measure of the purity of your compound, and obviously the yield is how much you've managed to produce. So this group managed to get 0.5122 grams, which was working out at roughly 34%. So that is fine. If you remember the last day as well, I'd highlighted for you that on a sliding scale you would get marks depending on how much yield you had and how close your melting point was to the final value. So some things just to remember is really the whole procedure relies on you being careful in transferring material from one stage to another. So in terms of your filtration, in terms of recrystallization, filtering again, all those sorts of things, you're bound to lose some product. But obviously the more carefully you work and the better you can transfer things from one stage to another, then the more opportunity you have of a good yield at the very end. I'd asked then just for the mechanism of the reaction. All you had to do there was to draw in the C6H5s in place of the R groups. So C double bond O on here, and you could just write in C6H5, which is the more straightforward way of doing it, or put in the benzene rings themselves. Only be careful always to try to connect the benzene ring to the rest of the structure, so make sure the bonds always connect up. So the comments really at the end were just a reflection on your part as to how you felt the practical had gone, but what things you could have done better, where material could have been lost, and all those sorts of things. Also, as I highlighted to you at the very start of the practical, if the sodium borohydride has been allowed to sit about for a while, it takes in moisture from the air, and it just means then that it's no longer as effective as it once was. So that can be an issue as well in terms of your overall yield and so on of the reaction. But generally this was well done. There was probably a bigger spread of marks this time because of the fact that we were marking you on your yield and your melting point. But again, right across the board, practical was done well, and if you have any queries, please do let me know. Thanks.
Okay, so we have dissolved our unknown compound with some distilled water. And now we're going to test if it's an acid or an alkali with some litmus paper. I'm going to use blue litmus paper, so that'll show if it's an acid or an alkali. So it's clearly going red, so that is definitely an acid. But I can double check that with blue litmus paper or litmus red paper. So if it's an acid, there will be no change. So there's no change, so it's clearly an acid compound. So we're going to take 5 centimeters of sodium hydroxide and mix it to some of our unknown compound, and if it is a phenol or a carboxylic acid, the substance will readily dissolve. So now we're going to decide if it's a carboxylic acid or a phenol by adding sodium carbonate, and if it is a phenol, it may dissolve, but there will be no fizz. But if it's a carboxylic acid, it will dissolve and there will be some effervescence. So we're going to test if this is a phenol or a carboxylic acid by adding 2 to 3 centimeters of sodium carbonate and see if we get a reaction. If there is a reaction and it's effervescent or fizzes and the compound dissolves, it's a carboxylic acid. But if there is no if the compound doesn't seem to be dissolving and there is no fizz, it's a phenol. So there seems to be some compound left in the bottom, so we would say that this would be a phenol compound. So we thought that our unknown compound was a phenol, so we did the ferric chloride test and we added it with water and the ferric solution, and if this was positive we would have got a violet colour, and then we did it with the ethanol and the ferric solution with our unknown compound, and if this was positive for phenol we would have got a green colour. So both of these tests show that we do not have a phenol what we first thought we did. So we're going to do the Brady's test to see if it's definitely not a ketone. So it determined that it's not a phenol, so we decided to do the Brady's test. So we did the Brady's test and we heated it up in the fume cupboard, and that showed that it was not a ketone or an aldehyde because there was no precipitate formed. So that means that it would have to be a carboxylic group. So we're going to make our little tubes to determine our melting point, so then we can determine what our carboxylic acid is.
Okay, so Vicky is filling our little tube to get our melting point. Takes forever.
And then once we do this, we're doing this so we get a good reading. So once we find out what our melting point is, then we will know what our compound is by looking it up on the table. So we're using the melting point apparatus to determine what our melting point is, and the melting point is when the last crystal dissolves. So then we will know our melting point. So we use the melting point apparatus, and for our first one we got 104, and for our second one we got 106 degrees Celsius. So now we're going to look it up on the table and find what our carboxylic acid is. So we got our 2 melting points and we look it up in the carboxylic acid book, and we look up our melting point and we find that ours was 104 and 106, so it was either these 2 compounds, but we were told by our lecturer that the compounds aren't very accurate, so we'd have to add 10 degrees Celsius on. So we added on the 10 degrees, so that would make it 122, so that means it's benzoic acid.
Okay, we're now going to cover the issues that were to be addressed in the video. This practical was all about determining the name of an unknown compound through a series of various tests. The practical ties in with our organic chemistry lectures, and it will help our understanding of the lectures and help us to further understand the organic chemistry that we've been doing. And the most difficult part of the practical was determining if some of the tests were a positive or negative result, as some of them it's quite hard to tell. The most enjoyable part was finding the result and getting it finished. The least enjoyable part was thinking that we actually had a different compound and carrying out loads of tests that we didn't actually need to do. And if someone else was to carry it out, I would tell them to make sure that they were sure of the results before carrying out a load more tests.